Okay, yeah, so thanks, Chair. Good morning, everybody. And actually, what Professor Bagnato just said is really true. But the problem of global warming is definitely similar in a way to this drug resistance, because for short-term benefits, you are willing to accept long-term regrets, actually, for short-term profits, whatever it is. So that's a big problem. Actually, I've given here at the Academy several times presentations on climate change, and every 6 months we have new results. So I can never give the same talk, so it will be updated clearly. Unfortunately, more to the sort of worrying side of the equation. And it's also, I think, well placed in the physics section, because it's more or less about the complexity science, which we apply to understand how dramatic will the climate change if we keep on perturbing it. So I'll give you actually the latest science on that, quite dramatic effects, but also the title, Down the Carbon Staircase. Yesterday in this final session we talked about what can be done about all that, and what the President just said, warning alone is probably not doing the job. You also have to come up with a really compelling story, a narrative, how we could lead a better life with the help of science, of course, with the help of technological progress, and where everybody would feel he's part of a new project of humanity. And this would be precisely this decarbonisation challenge here. So let me start. So this is just to remind you that when I gave a similar talk 2 years ago here, this is the development of global mean temperature since we have instrumental records, 1880. You see it's a typical physical line going up and down, wiggly, but you see a trend clearly, yeah? And the interesting thing is that it goes down a little bit, as we heard. That is natural geoengineering, pinatubus, or a lot of sulfur in the stratosphere. If you have an El Nino, like in 1998, and recently it goes up, La Nina, the cold sister of El Nino, so to speak, we have a little bit of cooling, and we do not really understand what happened around the end of the Second World War. There seems to be an uprise. Many of my colleagues think it's just bad instrumentation at the time, because many meteorological stations were lost or ill-maintained and so on. We have not solved this, but probably it's nothing that is against the overall trend. But what you see here in the last 3 years, we had a surge of global warming again. So there was this stupid talk about hiatus, perhaps. Global warming has stopped. Nothing has stopped. Quite to the contrary. So 2014 was the warmest year on record, also last year, and this year is also going to be the warmest year on record. Now, if this would be a stationary ensemble, the chance for this happening 3 consecutive years would be 1 in a million. So 1 in a million is not a good chance to just lay back and say everything is fine. So this is some of the most worrying things I've seen over the last 20 years. This is giving you the total global sea ice extent, so it's Arctic and Antarctica together. And you see this sort of ensemble of lines is giving you over the various years, 1995 and so on. But the red line is 2016. So you see it's a complete outlier. Something is going on in the climate system now. This is so far away from the normal, but obviously we have passed the tipping point somehow. That means the old ice is not existing anymore. Of course, when it's below 0 in the Arctic, it will freeze over, but it will disappear like on a pond in the summer, of course. So something has changed in the systemic setup of the climate. So this is the response, the human response. This is the triumphant sort of final session of the Paris Agreement. You know, you see Ban Ki-moon and Hollande Fabius and all those people, because it was decided on the left-hand side, the lower box, to keep global warming well below 2 degrees centigrade, and even to aspire for 1.5 degrees. But I'll tell you what it means. First, of course, I'll tell you why this is a reasonable result, absolutely. But I will also show you that it's almost unfeasible. And that is a big dilemma, clearly. Yeah? But we have a narrative for that. So this has to take you a little bit into the world of nonlinear dynamics. So I came up a long time ago with a map of so-called tipping points, tipping elements. Mario Molina is well aware of that. It has become an iconic map, really. It shows you, like in the human body, where are the vital organs? Like in the human body, if you have a major infection or you have hyperthermia, what are the first organs to collapse? The kidneys, maybe, things like that. Here in the planetary machinery, you have a number of vital organs like the big ecosystems, of course. I will talk about that later. Today, I think the Amazon rainforest and the pressure of agriculture on it. The Great Barrier Reef, which is probably the biggest organism on this planet. And when, of course, you have the ocean currents, the jet stream, and the big ice sheet. And I give you just two examples. When is the critical threshold reached for these vital organs? And for the ecosystems, in particular the tropical coral reefs, which are probably the most beautiful natural objects in the world, we found that with a warming of 1.5 degrees, you will already lose 90% of the tropical reefs. 1 degree we have already, so it's just 0.5 degrees away. And you see actually the evidence of that, the Great Barrier Reef in March 2016, in the northern part of the reef, 40–50% of the corals have died back because of bleaching. So the science on the wall, the writing on the wall is there, you just have to read it. And it's in big letters, really. And the second thing is, that is a theoretical prediction, but we have also measurements that with about 1.6 degrees warming, we will probably see the melting down of Greenland, and this is a self-amplifying effect, you know? Why? Because the ice layer is 2,000 meters thick or so on. So if it starts to melt, the height is reduced of the ice sheet, so it's getting warmer, right? It's in a warmer sort of area, and then it's self-amplifying, really. So once it starts, you cannot stop it anymore. Right? So this is the upshot. So I published this with my colleagues this year in Nature Climate Change. And this gives you, it's a complicated slide, but I'll walk you through it because it's very important, because it tells you why the right climate targets were agreed in Paris. You know, in Paris, I was member of the German delegation, but also advised the Vatican delegation, which was headed by Cardinal Turkson. So we had talks there, and I think the Vatican played a very important role for the Paris Agreement. This is for the history books, of course. It cannot be revealed today, but some people know about it. Marcelo Sanchez-Sorondo knows about it and others. So it played a very important role. But anyway, that's what happened. You see the wiggly line again is global mean temperature since the last ice age, so minus 20,000 years. And you see slowly we emerged from the ice age, which was just 4 degrees cooler. When we had this stable plateau, we called the Holocene, where we invented agriculture and everything. And then on the right-hand side, you see several options for humanity. The green scenario means we do just everything in order to stabilize the climate that will keep us below 1.5 degrees, actually. And in the long term, for hundreds of years, we would settle for 1 degree warming, which we have right now. When there are some intermediate scenarios, but we are actually on the red line right now. This is our current scenario. And it will take us now on the left-hand vertical axis, you see the temperature responses. It will take us by the year 2500 to 8 degrees warming in a conventional scenario. I'll show you a little bit later what the newest insights are in a conventional scenario. And when you have the Paris range, 1.5 to 2 degrees, where there is this horizontal gray bar, which is where we want to land spaceship Earth in temperature space. And when you see the error bars for the various tipping points or tipping elements, so on the left, the Western Arctic ice sheet, the coral reefs, so you see, even if we succeed with the Paris Agreement, we are already in the first group of high-risk events. So whether we can even stop melting of Greenland, we don't know. There is uncertainty, but we need a little bit of luck for that. But it would be completely irresponsible to go beyond that, because when the next group of red lights or stop signs will kick in, and finally we would even melt down East Antarctic ice sheet, that would entail sea level rise of 70 meters. So those people who have voted in Florida for Donald Trump are not aware that we will just sink Florida if this comes true and if the American policy is not taking account of the scientific evidence. Because this is with all populist movements in the world, they are against the Enlightenment, in a sense, against the scientific method. I mean, you either honor the facts or you disregard the facts, and you just believe in whatever you like to believe. So this is more than just maybe the US leaving the Paris Agreement. It is an outright war against science, really. So let me move on. And this is now a strange thing, actually, in climate science. With the models, we find that there is something like an almost linear relationship between global mean temperature change, so delta T, and the cumulative emissions. So what have you emitted over the course of time? Yesterday it was said that CO2 remains in the atmosphere for about 100 years, but within the overall system it remains for more than 30,000 years. That is a fact very few people know. So in a sense, it's longer lasting than plutonium. Why? Because it's absorbed by trees, it's by ocean sediments, but it's re-emitted actually after a while. So the disturbance doesn't go away until you wait 10,000s of years. So the cumulative emissions and the warming is, with all the uncertainties, more or less a linear response. So you can now, if we go on, you can now calculate actually how many emissions are left, or since the beginning of the industrial age, now we put it at the year 1870 here, a little bit later, how much cumulative emissions are allowed for what time of warming. And you see here the black quadrangle is 1 degree. So it's less than 500 gigatons of pure carbon now. It's not CO2, it's carbon. So if you turn it into CO2, you have to multiply it by a factor of 3.66 because CO2, the atomic weight. So you see, we have already exceeded this budget because we have already emitted about 500 gigatons. 1.5. So it's about 700 gigatons. And finally, 2 degrees, it's sort of 850 and so on. So we are so close to that already, and I'll show you in a different way. So why is this, and that's the physics part of my talk, why do we have this quasi-linear thing? First of all, with all the models you see, it doesn't matter how you emit, whether you emit a lot in the beginning and when you slow down, or you do it in a linear way. In the end, that's the lower panel, you always get the same temperature. So it's independent of the path. It's also independent of the overall volume of emissions. And that's a big riddle for us, actually. There's one explanation, I will not go into the details, how the various things cancel. So why does the complex climate system respond roughly linearly to cumulative carbon emissions? Well, on the one hand, and this has been known since Svante Arrhenius wrote his famous paper in 1896, which he calculated with pencil and paper, varies with diminishing radioactive forcing per unit mass of CO2. So if you have more and more CO2 in the atmosphere, there's a sort of logarithmic response. Logarithmic, so it is not linear, it's below linear really. On the other hand, and that's the left-hand box, the lower one, because our carbon sinks, the natural carbon sinks, in particular the forests, for example, are not just absorbing and absorbing all the carbon that is in the air. They may even turn into a source after a while. There's a higher airborne fraction. So far, we have only half of the CO2 in the atmosphere we have emitted, because a lot is taken by the oceans, and even more now by biological sources. As I said yesterday, the Siberian forests are growing like crazy because of this CO2 fertilization effect, because they feed from CO2 actually. Sunlight plus water, but CO2, yeah, I'm fine. CO2 will actually together nourish the plants. And when there is a decreasing ocean heat uptake for higher temperatures, that's just the physics of the system. So all in all, it more or less cancels. But there's now a new result, and that is quite worrying, really. And this is not to alarm you, but just tell you what the scope of the challenge is. It more or less says that the climate sensitivity, and Mario will in particular be interested in that, is asymmetrical. It's smaller, the climate sensitivity. That means you double CO2, what is the temperature response? And in cool times, it's lower than in warm times, actually. And this is the result of paleo records. So thousands and millions of data have been. And so the result is on the right-hand side, and you have to really honor this plot. The red plot means with all the uncertainty, but you can focus on the fat red line. This is the IPCC prediction of warming in the 21st century, this century, if we keep on doing business as usual. And you see the blue line is the reconstruction from paleo data, so going 800,000 years in time. That means the blue line, 5 degrees warming by the end of this century, not in 2500. And that is a step change in response. And this would be, in my view, the end of our civilization, not of Homo sapiens. So as Peter Raven said yesterday to me, some in the Scandinavia will survive, of course, but I cannot imagine we will have peace on Earth and we can feed decently 10 billion people with 5 degrees warming this century only. So I skipped that. So we had to go down the carbon staircase. And I show you the red envelope is what the nations have pledged in Paris, the so-called NDCs, nationally determined contributions. The blue envelope is how we have to reduce emissions. And you see we have to peak by 2020, when we have to go steeply down. We have to reach carbon neutrality by 2060 or something, and then you have to go negative. If you do now 1.5, it's the green envelope. We have to reach carbon neutrality by 2040. Yeah? But you can look actually what needs to be achieved for that. You see, you have to have carbon neutral economy. It means electrification of end uses, freight transport, aviation, shipping, the heavy industry, agricultural emissions. We'll talk about it later. The power sector, that's a very important message, has to be completely decarbonized by 2030. That means a coal phase out by 2030 at the latest is a no-brainer, really. It's a no-brainer. And later on, we have to even go negative by planting trees and so on. So this is the German Energiewende, which is one of the few examples in the world where such a disruptive change is. Now look at that, the green line is the renewable contribution to electric energy. It was in 1990, 3.6%, and you have the nuclear, the red one, and coal. Now you see what happened. Because of a tiny little law in the German government that was passed, the so-called feed-in tariff. So I can do it again. So you have this crossover. So nuclear is going down. We tried to work hard on coal and so on. And This year, 2016, electrical energy from new renewables is more than 35%, so, and it's going up. So we have a lot of technological progress to help us here. If you look at that, the costs have come down since 2008, so over 7 years. Land-based wind costs have come down by 41%. Distributed solar, small-scale solar, 45%. Utility-scale, large-scale solar, 64%. Battery cost, 73%. And LED bulbs, 94%. So this disruptive technology is available, but not the political will to use it. So it can be done in principle. So I skip that. Last thing is the co-benefits of decarbonisation. I have to emphasize that it was talked about yesterday. According to the WHO, you have 7 million people killed prematurely every year by air pollution, 3 million by outdoor air pollution. In China alone, 1 million premature deaths every year. So this is a massacre, really. And this is the big co-benefit. So I'll end with 2 quotations. This is a little bit, it's not tongue-in-cheek because it's too sad, really. So, Great Visionaries, Part 1. So, Malcolm Turnbull, the Prime Minister of Australia, recently said, coal is going to be an important of our economy. There's no question that it will for many, many, many decades to come. And now I'm a physicist. Many in my field means about 10, an order of magnitude. Now many times many is 10 to the third. It's 1,000 years. So, of course, he's not a physicist, so he can just talk about this. But this is crazy. I mean, it will not play a role for 1,000 years, although we have enough. And of course, we will take this step. The new narrative is from here, this is Beijing, but you could go to, we take this big step, of course, to renewables. I need to do it. And that reminded me of another great visionary, Earl Douglas Haig, the British Field Marshal, because it's now precisely 100 years when the Battle of the Somme ended, you know? The Battle of the Somme in 1960. It was the biggest massacre in the First World War, and the Germans and the French and the British were pitched against each other, and people were just killed by the thousands every day for nothing, absolutely nothing. And Douglas Haig even was quoted later on in 1925. He still said, you saw aeroplanes and tanks are only accessories for the man and the horse, and the horse will play a role also in the centuries to come. Now, this is the famous charge of the British cavalry in Waterloo in 1815, 100 years before. And this is how warfare looks like today. No horses anymore. So you see, on the one hand, people completely underestimate the value of progress and what science technology have to offer. On the other hand, you see very often governments and incumbent CEOs get away with that, and even they get honored and at the highest level for that. So I think we scientists have to tell this story, but there is a real alternative. We have to come up with this narrative that yes, the world can be saved, actually, and it will be actually for the benefit of most of the people on this planet, but maybe not for the richest 1%. Thank you very much.